In the last video, we named some fairly simple ethers. In this video, we're going to think about slightly more complicated ones. And in particular, what happens if in the process of having an ether, we actually have a ring as opposed to just a long chain. So you could imagine a molecule that looks something like this. You have your oxygen. On this side of the oxygen, you have this carbon chain right here. You have a carbon chain like this, but then that chain bonds back to the oxygen. So we have a ring here. And so it's not obvious how to name this. You can't just look at this side and call it, methyl, and then that side and call it methyl as well. It's the same side. It connects back to itself. So how do you name this type of ether? So what you do is you just number it. You number it. You number the longest carbon chain like we've always done in the case of an alkane. So this is, we can start numbering here. 1, 2, 3, 4. And so this, if we just think about the carbon chain by itself, we know if it's one carbon, it's the prefix is met. Meth, 2, it's eth. 3, it's prop. 4, it's bute. So if this was just a carbon chain, we would call this butane. So if we just looked, if we only looked at this carbon chain right here, this carbon chain right there, you would call this butane. You would call this butane. But obviously, this isn't butane. We have this oxygen that's bonding to the 1 and 4 carbons of the butane. So to make that clear, we call this, and let me color code this part right here, this oxygen right there. It's bonded to the 1 and the 4 carbons. So we call this 1, 4, and this is our new word that we're going to learn in this video, 1,4-epoxybutane. 1,4-epoxybutane. And it doesn't just apply when the ether forms a large ring. It can actually form a little subset ring on a regular chain. So you could imagine something like this. Let me draw a chain of carbons. Let's say we have 5 carbons. 1, 2, 3, 4, 5. Just like that. And then let's say that between this carbon and this carbon, instead of having a double bond, this carbon actually bonds to an oxygen, which then bonds to this carbon over here. And obviously, every carbon has 4 bonds. The ones that we're not drawing, those are hydrogens. How do we name this? Well, same exact process. We start numbering. We actually start numbering the chain closer to where the oxygen is bonded. So we start numbering at this end over here. 1, 2, 3, 4, 5. So this is pentane. This is pentane. And then the oxygen is bonded to the 1 and the 2 carbons. So we call this 1,2-epoxypentane. 1, 2 epoxypentane. Now, in the last video, I told you that in general, ethers are fairly non-reactive. They actually make for good solvents. But what I've just drawn here is a special case of ethers called epoxide. So when you just have this kind of three-atom chain right here, where it's 2 carbons and an oxygen, this is a special case of an ether called an epoxide. This is called an epoxide. And this, unlike most ethers, is very reactive. This is very reactive, or another way you could think about it, it's very unstable. This is very reactive. So sometimes people kind of consider these separate from ethers. And the reason why very reactive is this 3-member ring right here. There's a lot of strain on these bonds. These electrons, these bonds don't like to be that close to each other. If you actually tried to make it with an actual a model set with molecules, you would have trouble making it bend enough to actually make this bond. So this is highly, highly, highly unstable. And there's actually an alternate way to name epoxides. The alternate way, so this is a completely legitimate way. You can name it just like an ether with a ring. This is 1,2-epoxypentane. But the alternate way is to pretend like you had a double bond here. That instead of this oxygen here, you had a double bond. If you had a double bond here, this thing would be called, depending how you want to name it, you could be called 1-pentene. 1-pentene. That's if there was not this oxygen here, but if there was a double bond here. 1-pentene would look like this. 1, 2, 3, 4, 5. This is the 1 carbon. So 1, 2, 3, 4, 5. So this is what 1-pentene looks like. We've learned that many, many, many videos ago. Sometimes it's called pent-1-ene, depending on which convention. This is kind of the more common one. But we have this oxygen here instead of this double bond. We have this oxygen here instead of this double bond. So instead of calling it just 1-pentene, we call it 1-pentene oxide. We call this 1-pentene oxide, just like that. So both of these are the names for the same exact molecule. This makes it clear that it's an epoxide. That's kind of the special ether that is more reactive. This is just a general way that we name any type of cyclic ether. So let's just do one more just to make the point clear. Let's have a cycle branching off of a cycle. Let's have an epoxide off of another ring, just to make the point clear that these aren't too hard to name, but the first time you see them, a little daunting. So let's say we have a cyclohexane ring right here. So let's say we have a cyclohexane ring. So so this is cyclohexane. But let's say we have a little epoxy branching off of it, just like this. We have that going on. So if we wanted to make it clear that this is an epoxide, we would essentially first pretend that this is just a double bond. If this was just a double bond, this would be cyclohexene. This would be cyclohexene. Cyclohexene. If this oxygen wasn't there and instead we just had a double bond here. And you actually don't have to specify the number for just when you only have one double bond in cyclohexene, because it could have been anywhere and it would have essentially been the same molecule. But since we have this oxygen here instead of a double bond that's bonding to both of these carbons, we call this cyclohexene oxide. Cyclohexene. So this part right here makes us name this cyclohexene oxide. Or if we wanted to just name this as a traditional ether, the way we would do it, we would just name this. We would just name this cyclohexane, 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 and put the epoxy in front of it. And put the epoxy. Either of these are valid. And once again, you don't have to number it because you could call it 1,2 epoxy cyclohexane if you made this the 1 or the 2 carbon. But you know it's going to be on adjacent carbons, and it could have really been on any of these two. It could have been on the 3 and the 4, and it would have essentially been the same molecule. So this actually makes it clear exactly what the molecular structure of the molecule is. Well, anyway, I thought you would enjoy that. And in the next video, well, I told you that epoxides are reactive, so I'll actually show you a reaction with dealing with epoxides.